Have you ever thought about a sound so powerful, so incredibly intense, that it just stops being noise? That it becomes a physical force, a weapon you hear for just one split second before it literally tears you apart? Well, believe it or not, that sound exists. And to understand it, we've got to start by asking one simple question.
And that's really the heart of what we're talking about today. We're not talking about sonic booms from a jet or some painfully loud music. No, we're talking about a focused beam of acoustic energy that is so extreme, it can kill. And it all boils down to one single number. 235. That is the decibel level we are going to be decoding. It's the benchmark for some of the most powerful active sonar systems that modern navies use. And let me tell you, at close range, it is absolutely, undeniably lethal.
Now, to be perfectly clear, this isn't just noise. At this level, what we're talking about is a wave of pure kinetic force. And yeah, it's designed to find submarines hundreds of miles away. But what it does to a human body caught in its path, well, that's why we're here.
But to really, truly understand the danger here, we have to get into the numbers. And the physics it's fascinating, really. Because a decibel isn't what you probably think it is, especially when you leave the air and dive deep into the water.
So here's the crucial thing to get. A decibel is a relative unit. It's a ratio, which means its value totally depends on its starting point, what scientists call its reference pressure. It's kind of like having a ruler that starts at a different number depending on whether you're measuring something in the air or in the water.
Okay, and this is where it gets wild. You see that characteristic impedance? That's basically just a fancy term for how much resistance a medium, like air or water, puts up against a sound wave. Water is about 800 times denser than air, so it takes way more pressure to create the same intensity of sound. It's a much more efficient, and because of that, a much more dangerous conductor of acoustic energy.
So, when you do all the math, you combine the difference in that starting pressure and the impedance, you get this magic number, 61.5. To actually compare the energy of a sound in water to a sound in air, you have to subtract 61.5 decibels from the water measurement.
So what does this mean for our sonar ping? Well, our 235 decibel ping in water carries the same raw energy as a 173.5 decibel sound in the air. Now, that number might seem lower, but think about this. The absolute loudest sound that is physically possible in our atmosphere is around 194 decibels. Any louder than that, and the sound wave literally starts creating a vacuum.
So let me just say that again. This underwater ping packs 10,000 times more power than the loudest possible sound that can even exist in the air around us. The energy is it's completely off the charts.
And this quote just nails it. This is where we shift from physics to biology. At this point, you have to stop thinking of it as sound. Like the source material says, it's a shockwave. It's just like the one that comes from a bomb.
So what happens when that shockwave actually hits a person? The human body, it's mostly water, so the sound wave travels right into it without a problem. The problem starts when that wave hits the parts of you that aren't water.
Your lungs and your intestines, they become the primary targets because they're filled with air and gas. The pressure wave hits these pockets and just violently compresses them, then expands them over and over. This oscillation shreds the delicate tissue, causing catastrophic internal bleeding. The injuries are medically identical to what you would see from a high-explosive bomb.
And the effect on the brain is somehow even more terrifying. The pressure can create and instantly collapse these tiny bubbles in your spinal fluid, which creates mini shockwaves right inside your skull, causing a massive hemorrhage. At the same exact time, the different densities of brain tissue are shaken so violently that they just tear apart. The sources describe this, very bluntly, as the liquification of brain tissue.
Of course, humans aren't the only ones in the water. The impact of this technology on the marine environment is just profound, and it gives us another way to really understand its incredible power.
Just look at this comparison for a second. That mid-frequency active sonar source is rated at 235 decibels. A Saturn V rocket launch, right, one of the loudest events in human history, is pegged at 197. A jet engine that would rupture your eardrums is down at 150. This really gives you a sense of the sheer scale of the energy we are dealing with here. But for marine mammals, like deep-diving whales, the sonar doesn't always have to kill them directly. The sound itself can trigger such an intense panic response that they just surface way too quickly. This gives them decompression sickness, the bends, just like a human diver would get.
Autopsies that have been done after naval exercises have confirmed this is a huge cause of mass strandings. And this isn't just some hypothetical danger. In 2023, there was an incident between the Australian and Chinese navies that really brought this into the geopolitical spotlight. Sonar was allegedly used against divers, injuring them, and proving that this is a very real and very dangerous area denial tool.
But here's the final and maybe the most fascinating twist in this whole story. The exact same physics that makes sonar so incredibly destructive can also be harnessed for a completely different purpose: to save lives.
It's an incredible irony, isn't it? The very same acoustic principles that can cause a traumatic brain injury can be used at super low intensities to detect one. Former Navy sonar techs have actually helped develop biomedical devices that use sonar-like sensors to identify strokes.
And they are incredibly effective. Get this, in clinical trials, these biomedical sonar systems have been able to correctly identify stroke conditions in over 97% of cases. It's a fast, non-invasive way to diagnose patients out in the field. Think about that. The same physics, one application liquefies the brain, the other saves it.
Which brings us right back to where we started. From the mind-bending physics of a decibel to the paradox of its medical use, the story of 235 decibels is one of unimaginable power. But for anyone who might be caught in its path, it ends with this one chilling conclusion: that lethal ping would be the first and the very last thing they would ever hear.